Hi there, welcome to Raelene Maths. In this video I will solve a nonlinear inequality using a sign chart. Here I have a polynomial function in fully factored form, and I want to solve for the values of x that make that polynomial, let's call it p of x, less than or equal to 0. So the first thing we want to do is to get the roots or the zeros of the polynomial, and we do that by using the zero product property. We set the entire polynomial or function equal to 0 and find the values of x that make the function equal to 0 in height. So we get either x is equal to -1, or x is equal to 2, or x is equal to +1. I set up my sign chart as if it were an x-axis, because then that helps me to come up with the graph if I want to build on top of the sign chart afterwards. I list these three x coordinates in order, -1, +1, and 2. I'm not too worried about exact spacing here. Then I create some regions here with 3 x values, or 3 cuts on the x-axis. That creates 4 regions. And I'm just going to identify them by region 1, region 2, 3, and 4, from left to right, or from smallest to largest. Now for each root along the x-axis, I'm going to list its corresponding factor in a column. The factor that gave me the root of -1 is x plus 1, including the exponent of 3. So I'm going to list that factor first. Then I'm going to come up with the factor that gave me the root of 1, which was x minus 1 all squared. The exponents are important. Remember, in a sign chart, we are looking at products of positive and negative signs. And so if we have 3 signs versus 2 signs, there will be a difference in the answer. Negative times negative times negative is different from negative times negative. And lastly, we have the factor that gave us the root of 2, which is 2 minus x. We have to list it exactly as it appeared in the function. Now, normally people would take sample x values in each of the 4 regions and then plug into a table or a chart, which is how we get the name sign chart, a chart or table of signs. But I am going to do it slightly differently by thinking graphically here. And I'm going to imagine we've got 3 different color graphs, a red, then a green, and then a blue. And forgetting about the rest of the graphs, I'm going to look to see what x values make each graph positive or negative in height. So the graph of x plus 1 is the graph of x cubed shifted 1 space to the left. So that cubic graph would look something like this. I notice that the x-intercept of -1 makes the height of the red graph 0. But to the left of that x-intercept, the height is negative. So the y-coordinates would be negative for any x value in region 1. Meanwhile, for any x values in region 2 or 3 or 4 would give positive y values. So I'm going to write the sign chart for the first row as negative and then positive, positive, positive. So I'm going to remove this red graph so it doesn't clutter up our sign chart. And then I'm going to repeat the process for the green parabola and the blue line graphs. The green parabola graph is y equal to x minus 1 all squared, which is the x squared graph moved 1 space to the right. And I notice here that except when x is equal to 1 and the height of the graph is 0, the other heights for all other x values are always positive. And so this row is going to be very easy to fill in when we think graphically or numerically, because we square any non-zero number and we get a positive result. The last graph is a linear function, and we have y equal to 2 minus x, which is the same as -x plus 2. This is a line that has a y-intercept of 2 and a slope of -1. So we go down 1 over 1, down 1 over 1. The x-intercept is of course 2 because the x-intercept is the same root that we had already listed for that factor. So the graph that we visualize for y equals 2 minus x looks like this. And when x is to the right of the x-intercept, the y values are negative, but all other y values to the left of the x-intercept are positive. So I'll just clear up that graph and put positive, 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 and then negative. This graphical approach to the sign chart greatly speeds up the calculation, and it also prevents some small sign mistakes that might be made. Now we want to come up with p of x. I'm actually going to change the color of p of x here. I'm going to call it purple. And p of x ends up being, this x-axis by the way is kind of like an equal sign if you're doing sums or calculations. P of x is going to be a combination of the product of the red, green, and blue y's. So I have my red cubic factor times the green quadratic factor, and then multiplied by the blue. I'm just going to erase or move this over a little bit. The blue factor of 2 minus x. And so when I multiply all of those factors together to get p of x, I can look in each column separately and multiply or find a product of the three signs. And so in column 1, region 1, when x is to the left of negative 1, the purple y values on the p of x graph will be negative times positive, which is negative. In the second region, the product of the signs is positive. In the third region, the product of the signs is positive. And in the fourth region, the product of the signs is negative. Now we have the sign chart, but it doesn't mean we automatically have answered the inequality. So we are specifically looking for when the y-coordinates or the p of x function output is going to be negative or equal to 0. So we can see that region 1 makes p of x negative, region 2 makes p of x positive, region 3 makes p of x positive, and region 4 makes p of x negative. We also need to put the zeros. So I'm actually going to put my solutions in red because it'll stand out on the x-axis. The roots are the values of x that make the y values on the p of x graph equal to 0, and so I'm going to include the solutions of negative 1, 1, or 2 for my x values. I also want my x values from region 1 or from region 4 because they make a product or a result of negative p of x values. And so here we can see that the solution, the set of x values that satisfy the inequality, will be x less than or equal to negative 1, or x equal to 1, or x greater than or equal to 2. Now it would be nice to take a look at the graph of this polynomial function to see if indeed this is the case. When we look at the graph, here we have x plus 1 cubed times 2 minus x times x minus 1 squared. We are looking for where this 6th degree polynomial lies on the x-axis or below. And we have solutions of negative 1, 1, or 2, as well as to the left of negative 1 or to the right of 2. And that does seem to be consistent with our sign chart approach. Again, the reason I like the sign chart is because it's a tool that can help us to go one step beyond solving the inequality to actually coming up with such a graph. And we'll see how to do that in the next video. If you like the video, click like and subscribe to my channel. Thanks for checking out Raelene Maths.